like the one housed in this 10-story structure, built to deal with the fact that rock doesn't come in convenient sizes. Rock crushers.
The Metso Minerals 4265 Superior Gyratory Crusher. Total weight, 264,000 pounds. Height, 10 stories. Motor, 500 horsepower electric. Diet, 2,557 tons of stone per hour.
The 4265 is known as a gyratory crusher because of the motion that actually does the crushing. The relentless back and forth gyration that compresses rock against the chamber walls.
To give you a visualization, this crusher is just a giant mechanicalized nut cracker. That's the same principle. When you have two surfaces, hard surfaces closing together with a soft surface in the center. In this case, believe it or not, the rock is a soft surface. So it's two mechanically advantaged metal pieces coming together and compressing that rock, and the rock breaks down to a smaller size.
The process begins in the control booth that sits atop the crusher, where the operator has a front and center view of each 100-ton load as it's fed into the crusher's mouth. Water spray keeps the dust constantly under control.
All of our crushers are designed to work at a choke-fed position. It's because the rocks on top of the crusher help push down the rocks through the crushing chamber, and the rocks will actually crush against themselves. That's called rock-and-rock comminution, and it actually does a better job of crushing size materials.
Primary crushers such as this one can accept rocks up to 3.5 feet in diameter. Operator Pete Huff uses a hydraulic hammer to reduce anything bigger. At the core of the crusher is a solid steel shaft, up to 26 feet long. The cone-shaped mantle threaded to the shaft provides the crushing surface. The shaft and mantle were each forged as a single piece of steel.
The mantle itself, the main shaft, weighs in excess of 52,000 pounds.
This giant nutcracker is powered by a 500 horsepower electric motor. The motor drives a horizontal pinion shaft connected to a large crown gear, which causes the giant vertical main shaft to spin. The main shaft sits in a housing known as an eccentric due to its asymmetrical shape. As the main shaft rotates, it shoves the crushing mantle back and forth in an eccentric pattern, 170 times per minute against the chamber walls. The rocks don't stand a chance. The crushing mantle would be nothing without ultra-strong chamber walls.
The castings on this machine are cast steel. They're heavy ribbed cast steel, very strong chambers. They are wear-plated, protected with either a manganese concaves or a steel alloy concaves.
2 stories down from the control room, the crushing is in full swing.
Right now you're hearing the rocks being crushed against this outer chamber here, which is the top shell. This section right here is the top shell with the heavy rib that support all the crushing forces. From this joint below, it's called the bottom shell, and that's where all the mechanics of the crusher are. The eccentric bushing, the bottom shell bushing, the eccentric, and below that is a main shaft position system, which raises and lowers the main shaft.
The greatly reduced stone emerges below.
You can see the size difference between the back of the truck and what's coming off that conveyor. That's how much it reduces that rock through that first stage.
This highly efficient method, known as